I'm Christopher L. Sigwan, UPU student. I will be discussing about topic 6, 7, and 8.
Topics to discuss. Medium Access Protocols. IEEE 802 LAN Standards. The Network Layer and the Internet Protocol. What is the purpose of Medium Access Protocols, MAC? To define rules for orderly access to the shared medium. Fairness in sharing the shared medium. Efficient sharing of utilizing the bandwidth. Determine when to access the medium. Determine what to do if the medium is busy. How the channel are accessed by competing stations in a broadcast channel. Now let's discuss FDMA. FDMA, Frequency Division Multiple Access Protocol. Purpose is to divide the allocated frequency for multi-access for stations. A guard band is in place to prevent frequency overlapping from other station, therefore, eliminating interference. Bandwidth goes idle if the allocated frequency is not used by the assigned station. An FDMA illustration will be shown on the next slide. The blue colors on the image are the frequency guard that prevents overlapping. Radio transmission mostly used FDMA. FDMA protocol can be used with both analog and digital signal. In FDMA, the available bandwidth of the common channel is divided into bands that are separated by guard bands. FDMA also supports demand assignment in addition to fixed assignment. Demand assignment allows all users apparently continuous access of the radio spectrum by assigning carrier frequencies on a temporary basis using a statistical assignment process. The next topic is TDMA. TDMA, Time Domain Multiple Access. TDMA assigns a fixed time slot for each user or station. The user or station is able to transmit only at its designated time or slot. If the user or station misses to transmit on its own time, then it needs to wait until its designated slot is available. To prevent overlapping of transmission in time, a guard time may be placed between slots. TDMA is used in the digital 2G cellular systems such as global system for mobile communications. The major disadvantage of TDMA is the requirement that each station must have a fixed allocation of channel time regardless of whether it has data to transmit or not. The next topic is CDMA. CDMA, Code Division Multiple Access. CDMA station has its own code sequence to identify the hopping pattern. This technology is used in the military to secure the communication or prevent jamming the transmissions. CDMA combines spread spectrum technology with analog to digital conversion. The data is scattered across the frequency band in a random pattern. To illustrate CDMA time frequency hopping matrix, it looks something like this. The next topic is the Aloha Protocol. The Aloha Protocol was developed at University of Hawaii in early 70s for packet radio networks. Pure Aloha logic is simple. Whenever station has a frame to send, it will transmit. Station listens for maximum round-trip time for an ACK. If no ACK is received, the sender or transmitter resends frame for a number of times and then gives up. The receivers check frame check sequence for any errors and send an ACK if the packet is intact and has no errors. Pure Aloha has poor channel utilization if there is frequent collisions and there is no carrier sensing in Pure Aloha. This protocol is ideal only for a small network. Collisions happen when two or more stations transmit at the same time. Collision happens even when the last bit of a frame overlaps with the first bit of the next frame. An illustration of Pure Aloha protocol is shown on the next slide. The red color frame indicates collisions has occurred. The next topic is Slotted Aloha. Slotted Aloha. To improve Aloha channel utilization or performance, Slotted Aloha was proposed. Aloha time is divided into slots. Any station on the Aloha network can only transmit at the start of the slot. Collision can still occur if both stations transmit at the same slot. Since slots are divided into discrete interval of time, synchronization is required in Slotted Aloha. An illustration of Slotted Aloha is on the next slide. The next topic is CSMA. CSMA, Carrier Sense Multiple Access. Station that wants to transmit first listens or check if another transmission is in progress. In this method collision is lessened, thus reduce traffic on the medium. The CSMA process is like the flowchart on the next slide. If medium is in use, station waits before transmitting, else it will transmits. Collisions can still occur on CSMA protocol. Transmitter waits for ACK. If no ACKs is received, packet is retransmitted at a random time. By listening before transmitting, stations try to reduce the vulnerability period to 1 propagation delay. The next topic is CSMA/CD. CSMA/CD. CSMA with collision detection. In CSMA-CD, when frames collide, it garbles the data on the channel and the duration is equivalent to the length of one packet. The question becomes, how long should a station wait before retransmitting, after it has detected a collision? If collision is detected, a jamming signal is transmitted and transmitting station will abort their transmission. Thus, with lesser time wasted on useless transmission, the channel utilization is increased. CSMA-CD further improves performance of CSMA. Next topic to discuss is IEEE 802 LAN standards. The IEEE 802 LAN standards. Ethernet, defined under IEEE 802.3, is one of today's most widely used data communication standards. It finds its major use in local area networks, which is commonly called as LAN. Founded by Xerox Palo Alto Research Center in 1975. Ethernet dominant wired LAN technology, commonly used or owned by organizations. Ethernet uses CSMA/CD, which has this algorithm below. Carrier sense, wait for link to be idle. Is the channel idle? Start transmitting. Is the channel busy? Wait until idle. Collision detection, listen while transmitting. If no collision, transmission is complete. If there is collision, abort transmission, send jam signal, other station will abort transmission. Random access, exponential backoff is the algorithm used by CSMA/CD to generate a random time. After collision, the station wait a random time before trying again. Next slide is about the limitation of the Ethernet. Ethernet has limitations on length. The latency depends on physical length of link and also the time to propagate a packet from one end to the other. Sending adapter encapsulates packet in frame, which has the structure shown on the next slide. The Ethernet frame structure. Preamble is for synchronization. With 7 bytes with pattern 10101010, followed by 1 byte with pattern 10101011. This is used to synchronize receiver, sender clock rates. The destination address is the intended destination, source address is the sender of the frame. The standard requires the minimum frame size to be 64 bytes, if the data field is 0 bytes, the pad will be filled to meet the minimum frame size. The checksum field checks the CRC or the cyclic redundancy check, which is performed at the received side. If error is detected, then the frame is discarded or dropped. A screenshot showing the Ethernet frame captured by Wireshark. But I think only the payload is shown, all other headers were stripped by lower layers. Therefore, it is not shown or captured by Wireshark. Next topic is Ethernet cabling. 10-base-5 referred to as thick Ethernet, its limited 10 Mbps and a maximum of 500 meters can be extended with the use of repeaters. 10-base-2 referred to as thin Ethernet or thin at 10-base-5. Maximum of only 200 meters and 30 stations per segment. 10-base-T uses twisted pair cables. 10-base-F is fiber cabling. The last topic to cover in this discussion is the network layer and the Internet protocol. The network layer provides services to the transport layer. Its service may be a connected-oriented service in which a circuit is established first before communication can take place, or it could be a connection-less service in which a packet is transmitted and the packet hops until it reaches its destination. The main task of the network layer is to route packet from source to destination. The routing algorithm, which is the mechanism of routing packet to find the best path to reach its destination. In Windows operating system, you can use traceroute or traceroute command to check how many hops can a packet traverse to get to its destination, but some router may not reply to traceroute command for security reasons. The command is a good tool to trace the point of failure if ever all routers will just reply to the command. Dijkstra algorithm is the algorithm used to find the shortest path. There are quite a few factors in selecting path in which the packet must traverse to reach its destination. Distance vector algorithms use the Bellman-Ford algorithm. This approach assigns a number, the cost, to each of the links between each node in the network. Nodes will send information from point A to point B via the path that results in the lowest total cost, example, the sum of the costs of the links between the nodes used. Routers using distance vector routing protocols do not possess the topological information about the network but instead rely on the neighbors. Distance vector routing protocols such as RIP or the Routing Internet Protocol is sometimes called routing by rumor, because the protocol has to rely its neighbor's routing table to make decisions which best path to select. Another protocol used on the Internet which still can utilize serial communication is BGP. The Border Gateway Protocol or the BGP is an inter-autonomous system routing protocol. An autonomous system is a network or group of networks under a common administration and with common routing policies. BGP is used to exchange routing information for the Internet and is the protocol used between Internet service providers or ISP. Customer networks, such as universities and corporations, usually employ an interior gateway protocol or IGP such as RIP or OSPF for the exchange of routing information within their networks. The Internet Protocol or IP is specified in RFC 971. The IP datagram has 4 major functions. 1. Provide basic unit for data transfer. 2. Provide addressing. 3. Facilitate routing. 4. Perform fragmentation. IP offers a connection-less service. IP datagram Ethernet frame structure is shown on the next slide. IP datagram inside an Ethernet frame has this structure. IP addressing. IPv4 address classes. In the early days of the Internet, the IANA, Internet Assigned Numbers Authority, defined 5 classes of public IP addresses as shown on the next slide. IPv4 address classes. Class A range is from 0.0.0.0 to 127.255.255.255, while Class B has range of 128.0.0.0 to 191.255.255.255. The Class C has range from 192.0.0.0 to 223.255.255.255. While Class D range is from 224.0.0.0 to 239.255.255.255 and the last one is Class E which is used for experimental purposes. Class E which has the range from 240.0.0.0 to 247.255.255.255. Class C is commonly used by private organizations or even at home networks. IPv4 uses 32-bit IP address, and with 32 bits the maximum number of IP addresses is 232 or 4,294,967,296. This provides a little more than 4 billion IPv4 addresses, in theory. The number of IPv4 available addresses is actually less than the theoretical maximum number. IPv4 has its successor which is IPv6. Last 1998, the Internet Engineering Task Force or the IETF had formalized the successor protocol. IPv6 uses a 128-bit address, theoretically allowing 2128, or approximately 3.4 times 10 to power of 38 addresses. With nating or network address translation, IPv4 is still not exhausted and still widely used on the Internet. We have come to an end on our discussion. And I would like to thank you everyone, for watching, hope you learned something.